Hey guys, and welcome back to a new ultimate guide. In this case, it's about WorkManager, which I realized I don't have a video about yet on my channel. So here it is. It's a full guide about WorkManager that really teaches you everything from A to Z, from the ground up. You have to know nothing about it. You can just watch this video, and at the end you will have a really good understanding and a really good impression of what WorkManager is, how it can be used, and how especially you can use it in your project, and for what kind of use cases it actually makes sense. So what is WorkManager actually in Android, and when do we use it? WorkManager is, it is contained in the Jetpack framework, I think. Yeah, it is a Jetpack library, and it is used if your app needs to do something that needs to be executed really reliably. So even if your app is closed or even if the device is restarted, if you scheduled a specific task your app should perform, then WorkManager is the way to do this. So it will make sure that it will be executed even if the device is restarted, even if your app is closed, even if your app was killed or so. So if you have something to do that needs to be done really reliably, then pick WorkManager. In general, there are 3 different types of tasks you can have with WorkManager where it makes sense. On the one hand, those are immediate tasks, so just tasks that need to be done immediately, that will finish soon. Then you have long-running tasks, which, well, run long, for example, a large file download or so. And then you have deferrable tasks. So those are tasks that you don't want to do immediately, instead that you want to kind of schedule at a later point. And then what WorkManager does, it actually helps you to schedule these tasks. So it will either take a one-time task, so something you only want to do once, or you can also use it to schedule periodic tasks. So tasks that you want to do over and over again, given a specific interval. For example, if your app needs to synchronize with your server every 1 hour or so, then you can use WorkManager to do that. So your app does not need to be launched, but WorkManager will make sure that your task, that your synchronization process will be executed once an hour. And internally, WorkManager will just take your task and store it in a database. You don't see any of that. That's just how it works internally, so that it actually does not forget about your tasks, even if the device is rebooted. So all these tasks are just stored in a database. And even though I could now just go through the Android documentation and go through all the WorkManager topics step by step, I don't think that's really helpful to learn this. That's why I actually thought of a little bit more practical example. So that will really help you to understand how WorkManager, how that works, and when you should actually use it, how you can use it, how you can actually, basically take all its potential and work with that. Let's actually take a look here on my phone, where I will show you the app that we will build. Right now, you only see a simple start download button, because that's what will happen here. When we click start download, we will download a quite large picture from my website, basically my profile picture here from YouTube. And then we will take this picture that we downloaded, we save it in internal storage, and after that, we start another worker, so another WorkManager task, that will put a color filter on that picture. So these image processing tasks are usually, quite CPU heavy and something that makes sense to be done in WorkManager. Here we will add quite some artificial delay, so we can just see how that really works. Usually that would be much quicker than it is here, but you'll just see some delay. Let's just click start download and see what happens. You can see downloading color filter is blocked. It just gives us some information about the current workers, about the current task. Once it's downloaded, it will show up here, and you can see now it's applying the filter. And after 5 seconds, it will update the image with the green color filter here, which actually is done by 2 different WorkManager tasks. So you will learn how you can take these and also chain these together so that you have one WorkManager task that takes some input, has some output, then another WorkManager task receives that input from task number 1, gives us some output, and we can then make use of that no matter if our app is actually launched or not. But that's not it yet, what you will learn. You will also learn about work constraints, which means you can kind of set constraints that need to be fulfilled for your work to start. So here for the download, it of course only makes sense if your device is actually connected to the internet. So we can actually specify, hey, Work Manager, please only execute this task once there is internet available. And if you schedule it for like in 30 seconds, but the user does not have internet connection enabled or just isn't just connected, then Work Manager will keep that task and execute it as soon as there's internet. So you can try this out here. I can't show you this because once I turn off internet here, then it will simply close the connection. Since I'm connected via Wi-Fi, it will work. I tried it. So it will simply wait with that download until you then turn off airplane mode again or so, or just regain internet connection. And yeah, that's something that's really cool with Work Manager, not just about internet, but I will go through that in a lot more detail once we get to these work constraints. And you will also learn how you can simply show a cool download notification once your worker is active. Not sure if it shows up again. For some reason, sometimes it does not show up. Maybe the task is not long enough. Let's wait until this finishes here and then we can try once more. Yeah, now you can see download in progress. Yeah, not sure why it doesn't always show up, but yeah, with Work Manager you can also easily show such notifications, just like in a Foreground service. I would say, without further ado, we just jump right into it and start from absolute scratch here. All you need to make sure is to get the initial dependencies down below from GitHub, as usual. You can see two compose dependencies for a view model and a live data. Now that's just to convert live data to compose state, which we need to do here. We have coil to show an image URI in an image composable, which we need to do here since we save these images on our internal storage. We have coroutines. Actually, that's not Kotlin plus coroutines. That's a Work Manager dependency. Let's swap that out. Work Manager with coroutines. So there are different ways you can use Work Manager with. We will use coroutines, of course, because it's cool. And we will use Retrofit to actually download the image from my website to save it in internal storage. So far, so good. Main activity is completely empty, and our whole project is completely empty. So I would say we just jump right into it, and I will explain everything from scratch. So yeah. Enjoy. The first thing we want to do is we want to set up our API, our retrofit interface, which just contains a single function to simply download the image to our internal storage. So here in our root package, I'll just create another Kotlin file. I'll call it file API. Select interface, that will be a get request. And if you want to use the same image as I do, then simply paste this stuff in there. If you are too lazy to write this off, simply paste it from the GitHub link down below, and that will just be a suspend function get, or rather download image, and that will return a response of type response body. So that's just how we download a file with a retrofit. That's pretty easy. So in the end, we just get a byte stream or a byte array, and we can simply then, kind of take that stream and write it to our own memory. We want to also have this one here as a singleton. So I won't use any dagger here for dependency injection because I really want to focus on Work Manager. So what I will do is we will just have a variable here, instance, and we say by lazy, and here we initialize this. Retrofit.builder, we say base URL is, in my case, simply my website, and then we can call build and .create passing file API class Java. So we really don't need any JSON stuff here. We're not dealing with JSON responses. We just need this base URL here, and then we're ready to use this API. Cool, should work with any other image as well. Just that you have something. If you don't know what else you should use, you can also use this one. The next thing is we will create a so-called worker. What is a worker? A worker is basically a class that defines our Work Manager task. So let's just create this and we will see how this looks like. And this will be the download worker, because that's what the class really does. That's what the task is about. It should download our image. And this should potentially also be something very large. So to download an image, you not always use WorkManager, but you would imagine that's like a 1 GB file. And then that's a long-running task that shouldn't be interrupted, and that should also run reliably even if your app closes. We make sure that inherits from coroutine worker, because we want to use WorkManager together with coroutines. And we can dismiss this message here. We need two parameters. On the one hand, we need the context. On the other hand, we need so-called worker parameters. And these will contain more information about the specific worker. We will get to this, don't worry. Passing the context in our params here, worker params. And now this download worker needs to implement one function. We can press Ctrl I or just implement do work here. And that's the function that performs the actual work. You can see it's a suspending function. We can directly make our network calls in here. And we then return such a result, which comes from the WorkManager API. And the WorkManager API will then use that result to determine, okay, was that task actually successful? Was that download successful? Did something fail? Maybe we got an invalid response. Or should this actually be retried later? Because that's also possible with the WorkManager. For example, here, when we download something and there is a server-side error. So we get an HTTP status code starting with 5. Indicating that there was an error that was the server's fault. Then usually trying that again later fixes this issue. So in that case, we could say, okay, WorkManager, please retry this request. Okay, so in this function, we now need to download our image using our API. First of all, before we do this, I want to show you how we can also show a little notification with this, because WorkManager already contains this behavior to easily show notification. Since in that case, if you have a long-running task, it will just execute that in a foreground service in the end. And as you maybe know, a foreground service is just a service the user is actively aware of. So the user knows, okay, this service is running because they will see a continuous notification. And WorkManager will handle all that foreground service stuff for us, but we just need to give it some information about the notification we want to show, of course. And when we want to show a notification, then we need to create a notification channel. That's usually done in an application class. So let's create that here, called download application. Inherit from application. And here, when we say on create, we can say we can just create our notification channel here. Let's actually take a look how that looks like. We only want to do this from Android Oreo onwards. So if build version, import build SDK end, if that's greater than or equal to build version codes Oreo, then we want to do this because before that version we don't need to create a channel. So we will define a channel here, his notification channel. Need to give it an ID. We can't use name parameters here. Let's just hard code this to download channel. Then a name would be file download maybe, or image download. And for the importance, what do we pick here? We pick importance high. Notification manager, importance high. Nothing really special here. If that's new to you, don't worry about it too much. We just specify some information about our about the notifications we send into this channel. And here we next actually want to get the notification manager instance using our context, which we already have since we're in the application class. So we can just say get system service context notification service. And I think, yeah, that's already it. Oh, we can also just say notification manager class Java. That should also work. And then we use this to simply create the notification channel, passing our channel instance here. And then we're good to go. We need to make sure that we take this application class and put it in our manifest here. Application name download application. And then we can jump back to a download worker, in which I want to now create a function that shows this notification. That will be a private suspend function, show notification. And here, since we are inside of this coroutine worker, we can simply say set, or how's it called? Set foreground? No, it is set foreground. So we have set foreground async. That does not need to be run in a coroutine. Or we have set foreground that is suspending, which is fine to be used here. That takes a foreground info, which is simply an object we can create here. And we need to provide a notification ID, for which you can just randomly generate one, doesn't matter. And a notification. So how our notification looks like, we can use notification compat.builder. Need to provide the context here. And the channel ID, make sure you choose the same channel name as you specified in your download application file. Usually I would create a constant for that, but I'm too lazy here for this project that isn't a real project. When I set a small icon, we need to provide an icon resource here. So let's do that. Let's import an icon. Or maybe we already have one. Let's check, are they drawable? Let's just choose the launcher icon, because why not? And then we can say set content text. That's the description. Here we can say, okay, downloading. We want to set a title. Download in progress. And then we can say that build. And there we go. We now just have a show notification function. Maybe we should rename this to start foreground service, because that's what it actually does. And then here in do work, we want to just immediately call this here. And then I want to simulate some delay of 5 seconds. As I said, we will just use this here so you can just better observe what happens when we click start download, because without this, everything would be happening very quickly. And for educational purposes, I think it makes sense to add some delay here. We'll also do this for the color filter worker, which we'll implement afterwards. That will put the green color filter on top of our image. And now let's see how it works to actually download a file using Retrofit. We simply get the response using our file API instance, download image. So we use our singleton. And then we check if the response body is actually not equal to null. So the body contains the byte information about our image now that we downloaded. You can see that's suspending. So we will only resume here if we actually downloaded it or if something failed. In this case, so that means the download was successful if the body is not equal to null. Then we just want to return a with context block using our IO dispatcher. So we just make sure that this coroutine is main safe, since what we now do is we read these bytes and save them on our internal storage, and that should be done on the IO dispatcher. So let's do that here. We first of all want to create a file object here to specify where and how we want to save this, specifying a parent, so just the path basically, for which we can use our cache directory. Usually that's probably rather something for like a temp files or wherever you want to save that, like external storage could also be probably more a thing. However, that requires some more setup. You need permissions, scope storage. So I really wanted to leave that out, and I will pick the simple option here of simply saving it in our cache directory, which belongs to internal storage. And the child is simply the file name, which I will pick image.jpg for. It's that easy. Then we can construct an output stream to simply save that file using that output stream. That's a file output stream. And we pass our file in that. And we see we get a little warning, which we can get rid of by adding this annotation here. Suppress this for the class. It basically thinks we're doing this on the main thread, even though we aren't, since we are inside of a suspend function. But yeah, it doesn't know that, because it's an old Java API or the old Java warning. And then we can say output stream.use. Here we get an instance to this stream, which we can now actually use to write something into this. I'll use a try and catch block here, since we want to catch IO exceptions in case something goes wrong. In the try block, we want to say stream.write, and well, that now takes a byte array of bytes that we want to write into the stream, so into this file. And this byte array comes from our response body from Retrofit. So we can just say body.bytes. And here, if we got an exception, so if something went wrong, we want to return with context. Now we need to return a result. So I want to say result from WorkManager here, listenable worker, dot failure in this case, because something went wrong. You can see we can either just normally return a failure or with an output data object. Do we want to attach some output data here? Yeah, we do. So in this case, we could simply pass an error message of what went wrong, so we actually know that. And we can simply do this by constructing a work data of object. And that's pretty similar like a normal map. So just a list of pairs, you can say. And we can simply construct these using a key and a value. So we can say, okay, this type of key contains that value, which is the data we want to then later access in our UI. And for that, I will create a little constants file. So here, worker params, which just stores the single keys we have here. And that's on the one hand, the error message. That's the imagery that we will later simply save here to know where we actually find the saved image. And that is the filter URI. So that will be the image URI of the successfully filtered image. So the image with the color filter. So we will just save 2 images here. So we just keep them both just for reference. You can also override the other one, then you don't need the second key. Over here, we want to map the worker params. Let's better call it worker keys, I think. So shift F6. Worker keys.error message to e.localized message. Because that's what we want to return here. Cool. Then what's next? We now still get an error because that does not return a result here. Like if everything went well, it does not return a result. So down here, if we reached that point and we haven't returned here, we know everything was successful. So we can say result success. And boom, the error is actually gone. However, we also want to attach some data, of course, in the success case, which is our imagery, where we save that image in the end. So same game as before, work data of, and this time we say worker keys, imagery, and we map this to our file URI. So file.toURI, make sure you use this URI, not this one, and toString, because we can't put URIs in this work data object. We need to use primitive data types and strings and stuff like that. And we can then later just reconstruct the URI out of that string. Cool. So now we consider the case that we got a response body. What happens if we did not get a response body? Then that means we would actually go on down here, and then we need to check what went wrong. So if the response is actually not successful here, we're gonna find out what was actually not successful. So why it wasn't why it wasn't successful. So we can check if the response code, like the HTTP status code, toString starts with a 5. That means we got a server-side error, as I mentioned already. In that case, we would like to retry our request at a later point. So we can simply return result.retry. It's really that easy. However, if the response code started with a 4 or a 3, which is also an invalid or an error response, then that means that was an issue of the client usually. So in that case, we don't want to retry it. So we can say return result failure, passing our work data off again, this time again with worker keys, error message to invalid server response or so. Or we can say, I don't know, network error. And after that if statement, if it was successful and reached that point, which should never happen, we can return result.failure with maybe simply an unknown error message, unknown error. Cool, and that's our worker. That's our worker that will now work independently of our app. So even if we start this worker and then we close our app, it will go on. If we schedule this worker, for example, in 10 minutes, and then we relaunch our device, then it will still fire off. So it will still be scheduled and be executed then in 10 minutes or when the device is launched the next time. So that's pretty cool. However, we want to chain this now with a different worker. And that will be the worker that will put the color filter on top of this image to save it again. And yes, we could theoretically also just do this here. This will probably save some work, but I want to show you how we can actually chain this and how another worker can receive the input from worker 1 basically, and how we can then finally get the result in our UI. So let's go here, root package, and create our color filter worker. Select class, same parameters as before. Like this, and make that inherit from coroutine worker, passing these two values and implementing do work. Cool, so far so good. That is already nothing new. However, this worker now actually takes some kind of input data. So since we launched this, of course, and after our download worker, it needs to have the URI as an input type where it can actually find the image it should put the color filter on. And how do we get this? Well, image URI. And we can now get this using these worker params that each worker needs to implement. You can see we have a bunch of fields here. And one of these is input data. So we can use that. And that just gives us these key value pairs we passed from our other worker. So we want to get the string, worker keys, image URI, of course. And then we want to transform this to a URI, since that's now a string that we got, and that to a file. So we have the file again. And let's actually rename this then to just image file or so. And that's how we now have the file in this worker we can now use to create a bitmap out of that and simply put a color filter on that. And again, I want to put a little 5-second delay here so you can see that better later. And then we can simply return image file .let. So we just make sure that's not equal to null. And in that case, we now want to get that file as an editable bitmap, because that's how we can simply put a color filter on that. Well, bitmap is equal to bitmap factory decode file. And we can simply pass file.absolute_path. And that would give us the contents of that file in form of a bitmap. Then we want to have a result bitmap, so the new image with the attached color filter, which is equal to bitmap copy. So we create a copy. We use the same config as we have for bitmap, and for isMutable we say true, so we can change it. Then to use the color filter, I will use a simple canvas. So val paint is what we need for that. So we simply create a new paint object. Yeah, that's fine. And we want to say paint.colorFilter is a new lighting color filter, for which we need to specify these mul and add values. I have no idea what that is exactly for. Mul is definitely the color that we want to attach, but yeah, just specify what I specify here and it will look green. So just a color in hexadecimal format, which is 08FF04. That's my green type. You can choose any color you like, and the add value will be 1. Then we can construct a canvas out of that bitmap. Android canvas, make sure you don't import the compose one. If you want to learn everything about canvas, check my courses down below. I have a very detailed course about that. The result bitmap here for the canvas. And then we can say canvas.draw bitmap. Passing the result bitmap, we're going to start from the very top, so 0F for left and top. And we pass our paint object, which contains the color filter. Cool. And now we simply need to do the same thing again to specify an output stream to save the file in internal storage. So we can simply say with context, dispatchers, IO, same as before. And here we will first of all specify a file, val like result image file is equal to a file from Java.io. Path name is, again, context cache directory. I'll call it, like, maybe, yeah, let's call it new image.jpg. We can then say, okay, we actually have an output stream. Same as before, file output stream, passing the result image file. Again, getting rid of this warning. And then we can see, okay, was saving that actually successful, for which we can use result bitmap.compress, and that's how we save a bitmap using an output stream. The format is a bitmap compress format.jpg, of course. The quality is, let's pick a 90%, and the stream is our output stream. It returns a boolean whether that saving was successful or not. So after that, we want to return if successful, result success with output data. This time we choose our worker keys dot filter URI to our result image file to URI, oh, not that one, to URI, this one, to string. So this time we choose our different URI from this file here. And else we say result.failure. And I won't attach any error message here. You can again use the same key for that and you're good. However, if we have a null image file here, then we still also need to consider that case. So this one here, then we would simply return result.failure as well. And we also won't do anything on the UI level with the error message from download worker. I just wanted to show how you can do this, and you will also know how you can access this value. So if you want to show this, then you will know how this works. So now we have our two workers. And the WorkManager knows how these work, how these should perform their tasks. However, we did not specify that these should actually be executed in this order. So first of all, the download worker and then the color filter worker with the corresponding inputs. So the rest will be now done in main activity, where we specify our so-called work requests. So we have a request to work, for example, to download our image or to put the color filter on our image. And then we need to tell WorkManager, hey, please have this first work request with our given constraints. Please only download when there's internet. And then have our second work request when the first one is actually finished. And please only do the second one if the device actually has is charging or whatever. You can specify all kinds of work constraints here. So first of all, here on create directly, outside of set content, we have our download request. And we can do this using one-time work request builder, because what we do is a one-time work. We don't want to download this image periodically. Like there's also like a periodic work request builder that you can use. And that will then take the type of worker you have here. So download worker, for example. And why does it give us an error? We need a duration parameter here. So repeat interval. That's basically the main difference between one-time work request builder and periodic work request builder. Here, you can just say, okay, I have duration dot, I don't know, of millis, of hours. Here, for example, every 5 hours, I want this to repeat the download. And then this will do this. However, we don't want this. Just that you've seen this one as well. We have a one-time work request builder. Of our type download worker, doesn't take any parameters in the constructor because we don't have any repeat interval. Now we have a bunch of ways to manipulate and change this work request. As I said, we want to add some constraints, and that has nothing to do with the constraint layout. Nope. We will actually specify constraints here. And we can do that using constraints builder. And now there are a bunch of different constraints we could make sure that they are fulfilled before starting this request, this download. For example, we can require that the storage is not low. So if you download a very large file, that makes sense to set this constraint. So that it would not start this request if there is not enough space on the storage. For the small image, I don't see any issues. Set required network type, that's what we want to do. We want to make sure that we actually are connected. So what we do is network type connected. So you can also specify I want an unmetered or metered connection or roaming, or not roaming rather. But we want to say, okay, we just want to be connected. If you have internet, then we're ready to download the image. Let's see what we also have. Here set requires charging, so battery not low. Basically, you can specify that if that is some kind of task that is very battery heavy, then you can specify that it's either charging or, yeah, not a low battery. And then it will automatically start once it is charging. So that's a cool thing about that. But I think we're fine with that. And we can just say build. And what else do we have? Input merger, that's something you can use to specify how different inputs and outputs are kind of put together, if they are overridden, if they are all capped. So if you have the same keys basically as inputs and outputs, then you can use that to specify something. We don't need this here. You can specify initial delay. So you can say, okay, please wait 10 seconds and then start the request, the one-time request. And set back of criteria that's used to, make sure what happens if you actually want to retry this. So in what kind of interval do you want to retry this? Do you want to do this consistently every 10 minutes or so, or do you want to start with 1 minute, then wait 2 minutes after that and stuff like that? That's what you can do. You can provide input data, of course. So if you want to provide data for your very first worker, then you can use this. And yeah, there's a lot you can do. Set schedule requested at. You can say, okay, at this specific time, it should be scheduled. So yeah, I would just say we say build and leave it like that. And then also do this for our color filter worker. It's one-time request builder. And here we don't need any constraints, so we can just say build. Then we can get an instance to WorkManager simply by using WorkManager.getInstance, passing our application context. So it's simply a singleton in the end. And that's how we get the instance. Now let's actually get to the UI and seeing how we now get the data from WorkManager to display it in our UI and to show the image. So the way this works with WorkManager is that we have so-called work infos. So that's a list of, work infos kind of. So objects that contain information about a specific worker. And we can get this by simply using our WorkManager instance, get work infos for unique work live data. That's a long name, but that's exactly what we want. So we now need to provide a unique name here, which I will use download for. So the unique work here basically means that there's only one instance of this work, of this task running at the same time. So we don't want to have two downloads at the same time. And this unique work is simply identified by this unique name download. And we want to get these work infos in form of a live data. So we get the consistent updates from WorkManager. Whenever anything changes, whenever there's any new data that we can get, we want to get that directly as an update. And since we're in Compose, we don't want to deal with live data, we can simply say observe as state. So we have that whole thing as a Compose state, and you can say that value, which will give us a list of work infos. Cool. And that now contains all the information about all of our scheduled WorkManager tasks. So let's see how we can in the end now get our two URIs, our color filter URI and our download image URI. We can simply, first of all, start by specifying a val for the download info. So first of all, just want to find the corresponding work info that is related to our download request. And then that is related to our color filter worker. Our color filter request, it actually is like this. We can do this using remember providing a key here. So whenever the key changes, it will simply refetch this remember block. So the key would in this case be work info. So whenever work info changes, we make sure we refetch the download info. And it would be equal to work infos. That find. We want to find the item where the ID is equal to our download request.id. So that's really easy. And then copy this. Do the same for the filter info. Also want to refetch this when work info changes just here. This should be our color filter request ID. And then based on these two infos, from these we can now get the URIs and also theoretically our error message if we would want to get that. So we can get the image URI here by a derived state of I will use, which will kind of cache the result of this block here. If you want to learn about these effect handlers in Jetpack Compose, then I suggest you to click here, where I go into that in much more detail than here. So it will basically just refetch this expression here, save it in image URI whenever it changes, and then notify all of its observers, so all kinds of composables that use this image URI, that there is a new result. So first of all, the download URI is equal to download info dot output data. That is the data object we now want to access. That get string, and the string that we want to get has the key image URI. And we want to get this as a URI. Then we can take this again, do the same for our filter URI. Choose filter URI here. Choose filter info here. And then what we want to return in this block is, well, the URI that we want to show in our image. That is our filter URI. However, if that's null, so if we have not returned that yet, retrieved that yet, then we will potentially already have the download URI, so the normal image URI, which we then want to display instead. So in that case, just download URI. Like this. And that's just now a normal compose state that we can use to observe the image URI that we get from WorkManager and show that in our UI that we now only need to build. And we of course need to launch our WorkManager requests. So we'll start specifying a column here that will just fill the whole screen. And we center the content horizontally and vertically. Then in here, we will have basically 4 items. So first of all, our image, then below that, our button to start the download, then our text that displays the state of the download process and the state of the color filter process. So if the image URI is not equal to null, we simply want to show an image, given that URI. Not a painter, though actually we do want to have a painter. I want to say remember image painter, which comes from coil. And for the data here, we can simply use our URI and it will display that. Content description will be null here. I don't care about that. And the modifier will be modifier filmmax width. And let's add a little bit of spacing below that image. Height of 16 dp, import dp. If we don't have an image, then we also don't want to show one. So after this let block, whoops. Let's simply have our button. When we click here, we want to launch our WorkManager request, so the download request. So what we want to do is we say WorkManager begin unique work. So again, this unique work is just to make sure that we only have one of this work type running at the same time. And you can also see if you want to cancel work, then you can also use WorkManager here. Cancel all work, cancel work by tag. You can also attach tags for work. Cancel unique work, given the unique work name, by ID, all that stuff. We won't cancel this here, but if you need to do this, then you're good to go. And you're good to use this basically. So begin unique work. You can see that returns a work continuation. So yeah, that's the name already says it, so we can continue after that with more work. And we want to do this. We of course want to chain this with our color filter worker. Let's start this unique work using our unique work name download, which we chose before. And well, what's the existing work policy? That is a policy that what should happen if there is already a work running with this unique name. Since it's unique, there can't be two instances of this work running at the same time. So I need to specify some kind of policy what should happen in that case. And we will use existing work policy .keep. So you can see append would simply just append this. So when the first work finished, I think it should go on with the second one. You have replace, append or replace. I don't even know what that is right now. Replace would simply replace the current work with the new one, but we say keep, which would basically, if we launch a download and the download is already running, we just ignore the second download request and wait for the first one to finish. And then here we need to provide a work request, which is our download request. And we can see we get a big warning because we don't call enqueue. That's what we always need to do. But before that, I want to say then to enqueue, or to rather specify the next work request that executed after this one, which is our color filter request. And then we can say that enqueue. So that is pretty cool. We just say begin unique work, and then we do our color filter work and we enqueue all this. So that's how easy we can now enqueue these work tasks. And we can actually also specify enabled here for the button. So whether this button is enabled or not, this should be enabled only if the work is not running. So if it's not active, if it is already downloading it, we don't want to enable the button. So we can say download info .state is not equal to actually work info .state running. So that's how we can check if the work is currently running. And in here, we just have a little text for the button, which just says start download. Cool. And after this button, the only thing that's missing are two texts. Let's have a little bit of spacer again. Let's say ATP. And then, well, the text is actually a conditional text based on the state of our work. So when it's enqueued, we want to show, hey, work's enqueued. When it's blocked, it's blocked. When it's finished, succeeded, whatever, we want to show that instead. So when download info .state, we'll use that and we'll use that again. If that is work info state running, we say text is equal to download, or let's say downloading. And then we can duplicate that quite some times, pressing Ctrl D. We have succeeded. Download succeeded. Oops, come on. This, then we have failed. Download failed. Cancelled. Then we have enqueued and blocked. So enqueued would mean, okay, you called enqueue and it's now waiting to be actually performed, the task. And we have blocked, which would, for example, be the case if it is, if it should actually be executed, but it is blocked, for example, by some kind of constraint or so. So download blocked. Cool. Let's have another spacer below this and do the same for our color filter. This time say filter info.state, applying filter. Filter succeeded, and let's replace this here very quickly. And there we go. That should be everything. So I would suggest we simply launch this. And there we go. Here we can start our download. And I already noted one thing I forgot, and that is an internet permission. Let's quickly change this in our manifest. Uses permission internet, like this. quickly relaunch this. There we go. And let's hope for the best. Clicking start download. You can see it's downloading. Filter is blocked, so it still needs to wait until the download finished. There's our image. Download succeeded. Applying the filter. And oh, that also worked. Cool. So it seems like everything worked. We can also see that the image was saved in our file system. If we go to this device file explorer here on my Android Studio, at least in the bottom right, this can give us a little bit of just information about the internal storage. We need to open this data directory, data again, and now we need to find our package, which is WorkManager guide. Open this, and here you have this cache. We save this in our cache directory, and here are our 2 images. So if we double click this here, we will see this image here in Android Studio as well. And that's basically the proof that it really downloaded these to our storage. Let's actually remove, or rather delete this app here, and I will show you something else. Let me quickly do this. Oops. Okay, I am back. I uninstalled my WorkManager app here. You can see unknown package. It does not exist anymore. So I will relaunch this. And I will show you that if we now simply start the download and directly close the app, and then wait a little bit, like over 10 seconds, then we should still see the image here because it should be all handled in the background. So maybe wait a little bit. And if we now say synchronize, here's our cache, and there are our 2 images. So that works perfectly fine as well. And that would even work if you relaunch the device and it is already scheduled, then it would execute that task as soon as you get internet connection. Cool. I hope you enjoyed this video, which was probably rather long, but this really covered 90% of what you need all the time with WorkManager, and the rest is very quickly just a Google search. If you want to learn more about this async stuff, like all this coroutine work here in our download worker, retrofit, color filter worker here with our dispatchers, and you really want to do this without making any silly mistakes, then you want to check out this video, which is about coroutine mistakes that most people actually do, and that can really ruin your project.